project, as you've seen, they sealed it up real tight. And so ventilation is a critical aspect of that. And so a little bit about the ventilation system and what we did involved with this project and what we do with projects. Tom told us about the project. He sent us a set of plans. He sent us some of the parameters of the project. And then what we did was we took this. So as I was saying, Tom told us about the project. He sent us a set of plans and parameters of the project. And then what we did was take those plans for this house and we plugged that into our design program. And we determined what the exhaust requirements are going to be for all of the bathrooms, the kitchen, basically our ventilation system. It's really bad. Our ventilation system is designed to where we principally exhaust out of bathrooms and kitchen, the wet areas, and we supply air primarily into bedrooms and also into living spaces if it's needed based on the design and on the plans itself. So we took that plan and we plugged in several parameters. One of those is the air changes overall for the house. So we took the volume of this house, and the passive house standard is 0.3 air changes per hour. So we took the complete total volume and figured out what that total number as a minimum of supply air and turnover in the house should be. Oftentimes what happens is then we plug in all the exhausts. We plug in all the bathrooms, and the passive house standard for continuous ventilation is 24 cubic feet per minute, 24 CFM per full bath, 12 CFM for a half bath, and 35 CFM out of the kitchen area. Oftentimes, on a house like this, where you'll have 4 bedrooms and the volume that it is, when you plug in all those bathrooms in the kitchen, that number can work out to be a higher number than the 0.3 air changes per hour to achieve the proper and code-required ventilation for exhaust out of bathrooms. So all those things are plugged in, and then what we do is we start to lay it out, and we'll take and lay out where supplies. You can look around here, you see the cans that are sticking down. It's got a white cap on it. So there's a supply over here. This is a large living space. So there's a supply. Those are actually returns out of the kitchen, right? Yeah. Yeah, I don't see any appliances. So yeah, those are returns out of the kitchen. We've got a return here. And you've got a return out of this right here, out of this bathroom. There's another return out of the other bathroom. Is that a bathroom there? No, okay. That back room has a supply into it. You can see that coming out. And then you'll notice in all those bedrooms, I don't know if you saw that, but you'll see where the supply diffusers were in each one of those bedrooms. And then returns come out of the bathrooms.
So how many CFM of supply is there?
You know, I think it's around the continuous ventilation. Do you remember, Tom, on that? I didn't look at the plans today, but
yeah, I have to look at the PSP.
I think the continuous. I'm sorry.
14 times 12.
No. Yeah, that'd be a little bit higher than what it is. So it's probably, it is 14 supply and 14 return ducts total that go into the house, into and out of the house. But it's I'm guessing it's about 125, 150 CFM. Does that sound about right? Somewhere in the 135 CFM. That's the continuous design ventilation rate for the house.
So the ERV would then be running 24/7?
At that rate.
Right. How much power would that consume over a period of 1 year? That's what I was wondering.
Well, I can give you an idea. I'd have to figure for this one, I'd have to, but to give you an idea, you're probably talking about, what's your electric rate here?
13 cents kilowatt.
Okay, that's less than what I was, I've got a baseline for projects we're monitoring in Vermont where at 65 CFM with another, this is a larger unit. This is a Comfort 550, which is a 325 CFM capacity. But it's a little smaller unit, but running at 65 CFM, it runs $2 a month. Okay?
$50 a year.
Right. Well, you're talking about $25 a year. So yeah, probably somewhere in the $50 for the year to run the ventilation system.
Passive house
Right, for energy use. And they measure that in watts per CFM. So our units use about 0.3 watts per CFM or less. Okay. Most North American units are about 1 or more. So we're half or a third as much as.
When you tell a conventional person, or when you tell some individual, yeah, we're going to get rid of the conventional furnace, the next thing they're wondering is, well, what is the CRV or HRV cost for electricity?
Yeah, it's nothing. It's in the amount of energy recovered, if you actually add that all up, it is the COP of our units is somewhere around 20. Okay, if you figure out how much energy was recovered to how much energy you used to do that. So it's a very, very high efficiency as far as that goes.
COP is multiplication factor.
Right. How many parts of energy in for what you get out? Yeah. Coefficient of performance. So electric resistance heat is a COP of 1. So a light bulb is a COP of 1. That's why they're not real efficient. Okay. A heat pump is anywhere from 3 to 3.5 normally. So the heat pumps they're putting in is a COP of like 3, 3.5. So the heat recovery ventilator is a COP of somewhere around 20. Okay. So, but the big thing is the ventilation and the fresh air that you're providing in a house that is sealed up and extremely tight like this.
In a conventional home, with respect to the filters, I know you didn't get the filters yet, but typical family of 4, you're having bacon and eggs and stuff like that, with respect to the filters in the kitchen, how many times a year do you need to change those puppies out? What's the approximate cost?
Depending on the units, some of our filters are actually cleanable and washable, so you can extend the life. We recommend at least once a year. Filters, a set of filters can run, say, $40 to $50 for a pair of those filters. In a lot of cases, okay, just real quick, there are 2 filters on each of these units. One's on the supply side, one's on the return side. So the return side's where you're bringing stuff out of your bathrooms or kitchens, so that may be different than the supply side where it has bugs and so forth, and you can vacuum it and solve problems there.
You really get bugs in there that far in one line?
Sure.
Can't you filter it out?
You can, yeah.
Hey, Barry, why don't you tell us how the whole thing goes together?
Well, yeah, I was kind of taking through, Tom, the step by step. So we designed the system, lay it all out, actually quoted all the materials to do this, okay? So we had all these points in here with the diffusers, boxes, supply diffusers, return diffusers, the unit itself, and all of the accessories, the controls. There's a main controller that allows change of speeds. It's got a timer button that you can just punch a button. It'll run for 30 minutes on high to boost and then go back automatically to a lower setting. There's also quite a bit of programming that can be done with our units. And then there are also these wireless bath switches which can go in the bathrooms. You can just punch a button for low, medium, high, or again a timer button. So you just walk in the bathroom and punch the button. It'll run for 30 minutes on high while you take a shower.
That boosts the entire system?
Yes. Yeah, because it is a balanced system, you have to do the whole thing. Okay. So that's the design. So we lay that all out. We shipped it all in here, and now they're starting to install it. And so what you've got is the unit. This is going to be mounted in here. You can see a supply and exhaust 7-inch duct. This is actually insulated ducting that is used to do the supply and exhaust. Keep in mind that the air coming in, if it's 30 degrees outside, it's coming in at 30 degrees. The air that's going out is about 32. Because the heat recovery ventilator is over 90% recovery efficiency, that means that the air that's leaving that unit is pretty close to what's outside. So both of those ducts have to be insulated to the outside. This is R5, and you can add insulation to that. You can wrap it and so forth. But unlike a metal duct that you would then insulate, the problem with that is oftentimes you condensate between the metal and the insulation, and that causes corrosion. This won't have any condensation, and then you can add insulation to it for just pure thermal.
Does this house have a preheater on it to condition the air before it goes into the ERV, so there wouldn't be a problem with preheating?
Frost protection, this unit will have, and actually we shipped this because we didn't have it installed, one with it installed, but it will have an electric preheater that's installed in it. So that's an option. There are different options that you have to do preheat and defrost prevention, okay? So that's the unit. This will be installed in here. What you see over here these are distribution boxes and also silencers. So there's a silencing material inside that. So a large duct goes in one end, and on the other end is a manifold with all this 3-inch duct. You see that 3-inch duct overhead? Yeah. And this silencer works pretty well. Because I'm yelling into that. And they're actually directional. You can see arrows on that. We've set these all up for supply return. You want one you have going to the supply side, the other to the return side. This house is fairly large, and we actually have an additional small distribution box that will be mounted downstairs. So we're going to run a T off with a 5-inch going down to the downstairs mechanical room, and the supplies and returns for the basement will be out of these two boxes. This is going to be right in this mechanical room, but you could run it and do it remotely. We've had projects like that where you have, say, a 5-story brownstone in New York. Well, we'll run a trunk line up to a 3rd or 4th floor, and where we've got a lot of ducting going, and reduce long runs of the smaller 3-inch duct. And we've done multiples where you've done, a set of manifolds in the lower floors and a set in the upper floors. So that's possible to do. Yes. Yeah, I mean, we had a project in California where they ran, we went out and looked at it. They ordered like 5 extra rolls of ducting, and we're like, what, that can't be right. And we went out and looked at it, and he had run them all the way from a crawl space all the way up. There was like a bundle this big going up to all the way to the upstairs. We had them run 2 trunk lines and took away 400 feet of duct. So we reduced it by that. So.
But naturally, you have this muffler system upstairs.
Well, normally it'd be right at the unit. On a normal, this is a large house, so we had to use multiples. But normally these would just go, we've got kits that mount them right on top of the unit. It's attached right here, and all the ducting just comes right out of that.
For each individual bedroom will be coming from.
Right. Yes. And those boxes you see, those diffusers, are set up for either 1 or 2 ducts into each one. We can put a plug in one side if it's a single, or run 2 into it. Okay. So they've put all the diffusers in. Now they're just starting to run the ducting. And this ducting, you can see some of it's hanging over there. There's an O-ring that is mounted, put right around the last ring on it. And that O-ring system is a clip. It slides right in there with an O-ring seal into that, and you just clip it into the next ring on the tube, and that's how hard it is put together. Leakage is 0, and it just goes right together. We're working with Habitat for Humanity projects all across the country, and the reason is that they have volunteer labor, and this is really easy for them to put in, and it works really well. They're actually building to passive house or similar in a lot of the chapters around the country. So we've got projects in Oregon, Wisconsin, Vermont, Washington, D.C., New Hampshire. Yeah, Kentucky, we haven't been working with them. That's somebody else. But yeah, they are doing passive house in the Kentucky, the whole state. So they're adopting this, and a lot of energy or affordable housing type things are adopting energy efficiency. Why build a house that you can't afford to stay in because of the energy cost? So.
I felt inside there, it's got a cloth material for nullifying the sound. Does that have to ever be cleaned? Or just clean
You can clean it.
You can clean
Yep, that's what these panels can come right off the front here. There's screws on those panels, and they can come off, and you can pull that whole rubber piece out of there and clean it.
Wash it off?
Yep. And that, it actually, there's like a surface material, but behind that is a BASF material that will not absorb moisture, but absorbs sound really well. So they're made for that. So that's the install on the house. So it's all designed. Yeah, I was going to grab a couple of the diffusers, and then that's the last part. Okay, so they're going to install this whole system, and when they get done, the last thing, there's a supply and return. You got one of the returns too? These are the last piece that mounts This is the actual diffuser. This is a supply diffuser. Kevin's going to grab a return diffuser. So this would be on the supply points, the return points, the kitchen and bathroom would use this other return diffuser. And we can adjust the flows in those just by screwing that in and out. The supply comes out 360 degrees along the ceiling and does this. The return diffuser is a cone, and that can also be adjusted with the height of that, and that's the return diffuser. So those go in, and the last thing we do at the end is come in and commission the system. The most important part is the commissioning, and what we do with that is we come in, the house needs to be virtually done, doors in and all the rest, so it's in living condition. We come in and actually fire the thing up and test the flows at each one of these. We come in with a hood and we put that on each one of these supplies and returns in the house, and we actually measure the flow. And we make sure that what is happening in the house is what we designed. And we check the bathrooms to make sure they've got 24 CFM return at medium speed, which is what we designed for the continuous ventilation. And what we do is we add up all the supply side and we add up all the return side and make sure they both say 135 CFM. Oftentimes that won't be the case, especially in a house like this is a perfect example. If you look, most of the wet stuff, the bathrooms are all here, and here's the unit. So they're all short runs. And then the bedrooms are all out there and over there, and they're all long runs. So your total duct length is much higher on the supply side than it is on the return side, which means there's more static pressure, more resistance in longer tubing, and also 90-degree bends are a very important factor. So when we add it up, when we run both fan motors at 50%, you'll have maybe 135 CFM on your return side, but the supply side with the longer runs was only running 120 CFM. We can go into our unit with the controller and we can change those fan speeds individually. So we would increase the percentage from 50% to maybe 55% on the return or the supply motor and get 135 on the supply, 135 on the return.
It's better to make the adjustment there rather than tweaking the registers.
Ideally, what we do is we try to get these all pretty much the same. What's the nice thing about running those home runs with all those individual ducts is it's, as somebody picked up on, it's about 10 to 12 CFM per duct is what we designed to. And so 2 ducts out of a bathroom is 24 CFM. And that's our design that we work with. But we don't want to try and, if you've got one that's running 20 CFM, we don't want to dial the thing way back. We'd rather adjust it at the motor. So we do fine tuning with these. The total volume we do through the unit.
You're saying from a design standpoint, it's best to keep your ERV or HRV closest to where the bathrooms are so you can get the moisture out?
No, I just say that's often what happens. The mechanical room is usually where all the wet stuff is, where the plumbing, they call it a plumbing core, or, you know, where's the builder here? It's the plumbing is generally grouped in the middle of houses.
What happens to all the moisture inside the ducts then as it's coming back? It's a long run. You're going to probably get a lot of condensation just with the moisture going through the ducts now. No?
Continuous ventilation, there's never a problem with that. It's just continuously being moved out. You may have some moisture in that duct, but because it's running 24/7, it's going to be cleaned out in short order. Well, he's talking if you take a shower and there's a lot of humidity in that, then you may have some, but it doesn't last because
You have to reach the dew point in a house that keeps its temperature.
yeah, it's not an issue at all. Yeah, this ducting, it's called Comfo tube, and again, there's some hanging down over there so people can look at it. It's made specifically for this kind of application. It's actually 2 layers. If you feel that, it's almost smooth inside and corrugated outside, so that it's got smooth flow through there. It's got to have a little bit of ridges inside, otherwise it wouldn't bend when you do 90 degrees and all. But this stuff, you can play around with it. It's pretty bulletproof. It's made of high-density polyethylene. It's actually made of a surgical grade, 0 off-gassing, 0 smells, and all the rest of it. So we have a certificate from Germany on that stuff. Our entire system, including the comfort air and heat recovery ventilation units meet living building challenge requirements. There's one piece of PVC pipe about this long that they stick in the box for your drain that doesn't. It's the only thing in the whole thing, which we threw out already, because we actually use a waterless P-trap that's made from polypropylene. Okay.
Is this commissioning part of the overall purchase price?
We do it right now, and this won't last forever. But as we're getting all going in the U.S., we've been doing that. So design on the front end and commissioning on the back end has been part of the service that we do when we sell systems. And that's Kevin's our rep for the Midwest, and so he's going to be working with this market on doing that. We are working with a national organization to train up their people, in which case they'd be charging for doing that. And it is a very, very important aspect of the system. If the system is not balanced, and we've got data on this, we're collecting on some of these projects around the country, a lot of it in Vermont with the Vermont Energy Investment Corporation, we've seen what happens when that balance gets off and the efficiency goes right off a cliff. So it's very important that the supply and return be balanced on the system.
Is that something you should check every couple of years, just keep making sure it's there? Or
From our experience, from what we've have a lot more experience in Europe over much greater time, it isn't an issue. No. And one thing is the ECM motors that we're using are very consistent and don't change. There are some cheaper motors that lose some of their efficiency and so forth over time, but we haven't seen that at all. So it's set, and if people mess around with these, you may have an issue with that a little bit, but it's not going to be enough. It's not going to be enough to change the balance of the system. One thing that we've had a big issue with in the market is tying ventilation into a air handler. Some people do. They put the supply air into an air handler, a return plenum of a furnace, for example, and use the air handler to distribute the air. And the problem with that, that's where we're getting some of this data. Every time the air handler changes speed or turns on and off, it changes the static pressure dramatically, and our unit goes. We've got data going from 60% to 90% recovery efficiency every time that air handler changes speed. So that's why we keep it separate.
Do you have your exterior hood in there, hoods here?
For the outside, we don't have it here, no. Yeah, I don't know if that was part of this, or normally it's part of the system. And our exterior hoods, you can take this, there's a straight pieces of pipe there. That would go all the way through the wall to the outside. It would be sealed with one of their gaskets, and the hood or the outside actually slides in with a gasket right into that, and then is just mounted on a plate on the outside. It's a stainless steel louvered screen. Yep, with a screen and a louvered opening on it. You know, square. They're pretty nice, you know. We had some others that weren't so nice, but these are better.
I've noticed online you have I think you call it not even combo, right? You have a heat exchanger that goes to a ground loop.
Yes, Comfo Fond L.
Is that a heat contributor, or is it only a frost?
It's frost and pre-cooling in the summertime. So he's asking about a ground source preheater, pre-cooler. And that's an option, an accessory in effect that would go with this unit. It mounts right next to it. It's a coil with a ground loop. So you take 1-inch HDPE piping, put two loops around the foundation of the house in general, somewhere in that range. And it's filled with glycol. And the unit itself has a small pump, small buffer tank, and a coil. And when it calls for it, it turns the pump on, and the air coming in goes across the coil and preheats it in the wintertime, or pre-cools it and dehumidifies it in the summertime. And as far as in a cold climate, real cold climates, it is the absolute most efficient way to do frost prevention, increase efficiency, and even do a little bit of cooling. In a passive house type application, we're getting the details on data for summer cooling right now on 4 projects that are being monitored in Vermont. And we'll have some data on that coming out later on this fall. We do have data from the winter, and we're seeing with an expenditure of 8 watts for the pump, we're seeing a lift on a 0-degree night of about 35 degrees. So it's going from 0 to 35 degrees with 8 watts before it goes into the Comfort unit. It comes out of the Comfort unit at 68 degrees in a 70-degree house. So the electric preheater is an 800-watt preheater, but everybody immediately cringes and says, oh my God, 800 watts, I'm running that. It actually only runs periodically as a defrost element. On that same 0-degree night, we actually have several projects. They're passive house, Habitat for Humanity homes that are being monitored. There's 3 of them in a row in a field in Vermont. And 1 of them has an electric preheater, and 2 of them have the ComfoFon ground source preheater. And we've been monitoring that. And the 800-watt preheater only comes on a 0-degree night. It was coming on about 3 minutes every 3 hours. So we'd see the spike in the electric use every 3 hours for 800 watts, and then it would go 3 hours, and it was consistent that way. So it doesn't run as much as, Peter Schneider, Peter, at the end of that, we looked at that, and at the end of the month, and then January, he looked at the numbers, and he's like, it's not that much. It wasn't as, immediately when you say 800-watt preheater, everybody gets crazy, but then you realize 3 minutes every 3 hours, a minute an hour at 800 watts doesn't consume a lot of power.
I wonder if the fuel loop would make it a geothermal qualified system for Texas. Then the whole system should be qualified.
Jeez, you're sick. You're sick, but that's an idea. I'll have to look into that.
So which one's most cost effective then? They haven't completed the study.
Well, the ground source system is basically the box is $2,000. So it's a $2,000 upcharge, plus the piping and putting it all together.
And the maintenance too. You have to look at future maintenance on it too.
No. I mean, if you use HDPE, it's good for 100 years. You might have to check your glycol, charge that. High density polyethylene.
It's cheaper than
It's cheap, it's easy, and it's good for 100 years in the ground.
200 PSI, 100 foot of it's probably only $30.
Yeah. You're talking less than $100. Less than $100 for the piping, and you just charge it and connect it. So it's not, it's probably a $2,500 piece add-on. But we're seeing some great things on the cooling side too, because what's going to happen is it cools the air coming in the summertime, and we have a bypass feature on most of our units, which it will bypass the exhaust air. Here's how it works. Summer bypass, and it's a good thing to have. In this house, Tom, have you looked at the heating side of things or the cooling side in the summer? What kind of loads do you have for anticipate? Yeah. Right. So what can happen with the bypass? What happens, and these days, right now, it's a perfect example of it. It's very warm today. The house is going to be warm, but tonight it's going to cool off. What happens is the house, you set a comfort temperature on this controller here. You set your desired comfort temperature in the house. You put it at, say, 75 degrees. If the house warms up above that, and the way we know the temperatures is there are 4 temperature sensors on this unit on each of those 4 ports. We know what temperature is coming and going out of all 4 ports in the unit. So it knows that the air coming out of the house is above 75. It gets up to 80 during the day, and that's 80 degrees going this way. And it knows that the air coming in is below that. A damper opens, bypasses that warm air around the core, and now the air comes through the filters and directly into the house. So when it gets down into the 60s at night, that's cool night air coming directly in and helping to cool the house. Now, if you add on a coil pre-cooler, ground source pre-cooler, during the day, it could accomplish the same thing. And we're actually getting the data monitoring on that right now. And we are getting some, about 15 to 18 degrees of cooling off of that coil on an 85-degree day. So the air's coming in somewhere around 70 degrees, and it's bypassing. And it's also dehumidifying it because it's a coil with 50-degree ground temperature. Yeah. Oh, yeah. It's a really good piece of equipment. You know, we've got a projects up in Alaska, Fairbanks, Alaska, where they're using that system, and their problem is it's the permafrost is 30-degree ground temperature, so they're not getting a lot out of the geothermal loop. But Thorsten is taking and he's putting his loop underneath the septic system. So he's getting about 40 to 45 degrees out of the ground loop, and on a minus 50-degree night with 70 degrees inside, he's got 67 degrees coming out on the inside. So he's getting 117 degrees lift. And he's using about 50 watts of power to do it. On the ERVs, yeah, all of our units are available as energy recovery ventilators or heat recovery. People want to know what the difference is. Heat recovery ventilator is strictly air moving through with the core inside of this transfers the heat with air moving through many, many layers of channels, and the air is coming from opposite directions through these opposing channels. And it's just made out of, in our case, plastic or aluminum, and it's just transferring heat with a heat recovery ventilator. An energy recovery ventilator or enthalpy recovery ventilator, instead of plastic or aluminum on those layers, it's a membrane. And it allows moisture to transfer through that along with heat. So if you've got 90-degree, 90% relative humidity air coming in, and 70-degree, 60% relative humidity coming out of an air-conditioned home, a lot of moisture and heat transfers from that hot, humid air to the outgoing airstream. So now what's coming in is, 75-degree air at 70% relative humidity. Enthalpy recovery is about 60 to 65%. Yeah, I don't have data on that, so we will. Okay, we are monitoring. We're actually monitoring before and after the coil right now to get some relative humidity to see what kind of effect it has on the humidity.
So in this climate, an ERV would be appropriate year-round. We have relatively high humidity.
Yeah, but
Of course, we're not burning fossil fuel inside to deplete moisture in the winter.
yeah, so yeah, people ask me, should I use an HRV or an ERV, and my answer is always the same: absolutely yes. So.
You wouldn't want to change one? You could take the core off.
Yes, ours are interchangeable. So, and in some cases in New York City, for example, where they have very hot, humid in the summer, they like the ERV, but they have moisture issues in the winter. They want an HRV so that they get rid of that inside moisture. They switch them out. So that's possible. No, it takes 5 minutes. Very easy. And there's a small change on the programming. You got to tell the unit I'm an HRV or an ERV. That's it. Okay?
ERV.
Yeah, I mean, sometimes in the cities like this, in an environment like this, ERVs are a little bit more prevalent. You have hot, humid in the summer. That helps a lot with, and an ERV in a hot, humid environment reduces your cooling cost, your cost of air conditioning, significantly. Because you're bringing in air that's at much lower humidity. It takes a lot less energy to dehumidify and cool air that's at a lower humidity than high humidity. We've got some data from Abu Dhabi and on the Arabian Sea, a little Swiss village there, and they reduced, by using ERVs, they reduced their cooling costs by 45%. So it can be significant. That's extreme. That's like 100 degrees and 90% relative humidity all the time.
So we should wrap up here. The night crew's coming in to start work, so. Right, man? Yeah. 20 minutes aside. No, so first of all, I hope that we answered most questions, and all of us are more than happy to take follow-up questions via email, and our cards are here. Are you guys going to edit this and do a...
Put it on the Alliance website.
Great. Well, why don't you say a little bit about the way the Alliance is working with the presentations and all that kind of stuff? All right.
Hello, everyone. I'm Mark Miller, Executive Director to the Passive House Alliance US. I wanted to quickly say something that this is a Passive House Alliance Chicago chapter event tonight that you're all attending. And one of the special things that has happened that hasn't been mentioned yet is that we have two of our board members who have decided to team up together to do an actual Passive House project. And I think that's just an excellent way that the Alliance is bringing professionals together, and that collaboration, you're seeing it firsthand. So the whole Alliance here in Chicago is very excited to see this happen. So kudos to you guys, Eric and Tom. I also wanted to mention that Zehnder is the newest sponsor to the Passive House Alliance US, and I'd like to give a quick round of applause to them for their support.
You were invited before.
So thank you very much. I also wanted to say that the Alliance, for those of you who aren't familiar with it, it's a member organization. We meet once a month downtown at the Heitfeld Center. We have presentations every month. There's going to be an interesting one in September on insulating existing masonry structures, which is kind of a very tricky situation for the high-performance building community. And we've got a couple of heavy hitters in the building science world who will be speaking to us. There's also going to be an event, Das House, which is a mobile passive house that is touring North America. It's going to make a Chicago stop at the end of September, from the 21st to maybe the 30th, is it? We have two members of the Das House team here,
Is the location
James
set?
and Meredith.
Are we? Great. So Daily Plaza is
Is it looking good? Okay.
good. That's as good as you can do in Chicago, I think. So. Yeah.
So the Chicago Alliance chapter is hoping to promote several Passive House specific events during this window while the Das House is located in Daily Plaza. And keep an eye out in the news and on the Alliance website for those. We're hoping to have some lectures and even some folks from FIAS to come up and talk about their experience over the 7-8 years now that Passive House has been growing in the U.S. Don't know at this point. It's yeah. The other thing we're hoping to do, it's not official yet, but we're hoping that there'll be another visit from during that September 21st to the 30th back here at the house. I'm sure it'll be a bit further along, and hopefully that might happen as well. So I also want to encourage all of you building professionals and supporters of the green movement and energy efficiency to Google Passive House Alliance Chicago and put your email address onto there, and you'll get emails of upcoming webinars and events and seminars and that type of thing. We also have the 7th Annual North American Passive House Conference, which is happening in Denver, Colorado at the end of September. There's news on attending that on our FAIAS website. It's phaus.org, so visit there. Also, if you have, oh, yes? Our Chicago Alliance, yes. There's information on, if you Google Passive House Alliance Chicago Meetup, it'll take you to our local meetup site. The Alliance website's a great resource if you want to learn more about Passive House, or if you have friends or colleagues who are interested in the concept. And you got a great tour today from the whole team that's putting this together, and you can see what a significant difference in performance and comfort and health that doing a passive house brings to a project. So if anyone's interested, just send them to the Alliance website, and they can see videos and articles and all kinds of great information. This video today of Barry's presentation and Tom's presentation will be on the website too if you want to share that with folks. And you can also find many other product manufacturers and sponsors of our Alliance on there with links to their websites, and like Kevin, the local reps in your areas if you have questions or you want to bring their products into your project. So other than that, I'm going to hand it back to Tom.
Okay.
And thanks for coming out, everybody.
Yeah. I think that's it. Thank you all very much for coming. Thanks, Brandon and Eric.